You run dehumidifiers, scrub baseboards with bleach, and dry every surface. And yet, the mold returns weeks later, creeping back up the exact same walls. When moisture consistently reappears indoors, the first instinct is to look for a liquid source. We assume it's a leaking roof, a seeping window frame, or a burst pipe behind drywall. But often, the building is completely watertight. The real culprit is invisible. A home is a massive, interconnected breathing system, and its airflow is governed by pressure. This gauge measures indoor air pressure in pascals. In a healthy home, pressure stays relatively neutral, sitting between 0 and -2. But if pressure drops to -8 pascals, it creates excessive negative pressure. The living space effectively becomes a giant vacuum. This vacuum acts as an invisible pump. It drags heavy, humid outdoor air through the microscopic gaps around windows, doors, and electrical outlets. The house imports gallons of water vapor directly into the living space, creating a perfect mold breeding ground without a single pipe ever leaking. To understand why a house starts pulling in outside air, we have to look past the living room and examine the hidden engine of the home, the HVAC ductwork, snaking through hot attics and wall cavities. Over time, the violent temperature swings in an attic take a physical toll on these ducts. The mastic sealant dries and cracks, the foil tape peels away from the metal joints, and as the house naturally settles, the inner liners of flexible ductwork can pull apart. Looking at this cross-section of a home's ductwork, we can see exactly what happens when those connections fail. If there is a gap in the return duct, the side of the system that inhales air, it acts like a straw, sucking sweltering attic air directly into the home's supply. The physics work in reverse on the other side. A leak in the supply duct blows conditioned air into the attic. Because the home is losing air volume, the house is forced to pull in hot replacement air from the outside, through utility chases and window gaps, to equalize the pressure. Once that humid outdoor air breaches the walls, it collides with the cold surfaces of the interior drywall and the metal air conditioning vents. The sudden temperature drop forces the moisture in the air to condense into liquid water beads. A mechanical failure as small as a quarter-inch gap in an attic duct forces the interior climate to mirror the humid outdoors. The HVAC system now acts as an active moisture delivery engine. Escaping air is invisible, which leaves investigators with a dilemma. To prove a hidden leak exists and measure its severity, mold assessors must rely on specialized diagnostic tools. The primary instruments for this job are a calibrated testing fan and a digital manometer gauge. The testing protocol starts with isolation. An investigator places airtight adhesive masks over every single supply and return grill inside the home. This separates the duct system from the ambient air in the rooms. Next, they attach the calibrated fan directly to the main return grill using a flexible tube. A small static pressure probe is inserted through the mask of a nearby supply vent, connecting the hidden ductwork to the digital manometer. This diagram illustrates the pressurization phase. The fan activates, pumping air into the sealed duct system until the pressure inside the tubes reaches exactly 25 pascals. With the ducts fully pressurized, the system's flaws are exposed. The manometer measures the exact cubic feet per minute of air escaping through hidden gaps in the attic or walls. The computer then calculates that lost volume to establish a total duct leakage percentage. This test bridges the gap between the symptom and the cause. It takes a subjective feeling of high humidity and transforms it into hard data that identifies where the building is failing. Knowing the exact leakage percentage changes the strategy. The homeowner can stop the cycles of surface cleaning and shift their focus to targeted structural repair. Fixing the system requires physical solutions. Contractors seal leaking duct joints, patch open utility chases, and recalibrate the HVAC blower speed to match the corrected airflow. With the system sealed, the air conditioner can effectively remove moisture. The environmental goal is to keep indoor relative humidity between 45 and 55%, starving the mold of the water it needs to survive. The home transitions from a high-pressure vacuum back to a state of balanced equilibrium. Solving a mold crisis requires addressing the physics of the building. Restoring the air pressure balance removes the moisture supply, permanently protecting the home.